Okay, so question 3 is a classic, just a standard hypothesis test for normal distribution. So we've got to read all the information, we've got to make sense of what type of hypothesis test we're doing, but as soon as we see this, and as soon as I see this, normally distributed in significance level, my brain switches into I am doing a normal distribution hypothesis test. Okay, so we think about how we do that. They're already telling me what X represents, so I don't need to write that down again. So H0 is that mu is the mean that I've been given. H1 is that mu, and I've got to work out, is that greater than, less than, or not equal to? So it is thought that women may have a different, not equal to. If it had said it is thought that women have a lower, then I would do less than. If it had said it is thought that women have a higher, I would do greater than. Okay, it just says different, so it's not equal to, which means this is a two-tailed test. Okay, I've got to say what mu is. I've used this symbol mu and I've not explained what it is. So where mu is the population mean. Okay, or the mean reaction time of all the women. Okay. All right. So we've done that. Then, so I know that X was normally distributed. So if H0 is true, then X is normally distributed with a mean of 355, standard deviation 52. Okay. So that's 52 squared because that was standard deviation, isn't it? So I now need to do my distribution for X bar. So X bar is normally distributed the same mean. The standard deviation gets divided by 25 because 25 is the sample size. Okay, so 25 women have been selected. Okay. So this is the distribution of the sample means. We have taken a random sample of 25 women. The mean reaction time is 344. That's lower than this. So we're doing a test at the lower end, okay? Because it's lower than my population mean. So we're testing at lower end with a 2.5% significance. I need to know the probability, because it's a lower end test, the probability that X is less than 344. And I'm using my standard deviation, normal distribution, lower limit's already in, upper limit 344, sigma 52 divided by 25, mu 355. That's not right.
So, you did 52 and 25. 52 squared over 25.
Shouldn't be. Shouldn't be. Yes, you're right. What have we done? What have I done? I mean, this is going to be a really entertaining part of the video, isn't it? Is where Mr. Owens figures out what he's typed in correctly into a calculator. That's too small. That's
what. 52 squared over 25. So you get 108.1.
No, that's not right.
So you need to go with it.
And then that's right. So it should be 52 squared divided by 25, then square rooted. That's right. So this bit's wrong. Oops. So remember, for x bar, your sigma is equal to the square root of sigma squared over n. Okay, and I've done sigma over n. That's why it all went a bit wonky. So we've got this probability, 0.1451. I now need to test that against my significance level is way bigger, greater than 0.025. So reject H1, accept H0. That is not enough to finish the question. I have enough evidence to suggest that women have the same reaction times as men. And you've got to put it in context. If you don't put it in context, you lose that last mark. Okay? Apologies about the weirdness in the middle of that question.